Hello all, this is Farhana. Welcome to my channel. In this video, I am going to talk about what are the key developments in 2023 for data science, machine learning, AI and analytics developments. In 2023, we witnessed an ever-growing, cross-industry and robust adoption of AI algorithms and data science techniques, both among data citizens as well as in large organizations. 1. Digital twins. We have seen large-scale digital twins of physical processes that are complex and multi-scale, such as weather and climate models, seismic phenomena and material properties. Big companies are already involved in digital twin technology. The McLaren sports car has its own digital twin. Companies like Siemens, Philips, IBM, Cisco, Bosch and Microsoft are already miles ahead in this technology, fuel the fourth industrial revolution. 2. In simple terms, doing more with less means to utilize something or a situation to the maximum possible level. 2023 was a tremendous year for the global economy. The world of data science was directly impacted as organizations began to emphasize saving money and doing more with less. These changes created two significant trends. First, data teams began increasing the reuse of machine learning (ML) features, and second, new ML technology tools that optimize the ML development processes became widespread. The agenda to do more with less will continue to be a top priority as we enter 2023. We expect this trend to drive growth in selected investments for technologies that help automate processes for the analysis and use of data, whether it's for the development of ML models or advanced analytics applications. Platforms that help data scientists and engineers do their jobs better, faster, and with less assistance from subject matter experts will continue to be in high demand. 3. One area that we have witnessed progress on this year is responsible AI, and 2023 should be the year that we see accelerated governance and adoption, as well as concrete frameworks in place, to deliver what should be our united goal of responsible AI becoming the norm for every organization. Their principles underscore fairness, transparency and exploitability, human-centeredness, and privacy and security. For instance, Microsoft has created its own responsible AI governance framework with help from their AI, Ethics, and Effects in Engineering and Research and Office of Responsible AI groups. These two groups work together within Microsoft to spread and uphold their defined responsible AI values. 4. In data science in the past 2-3 years, the most exciting developments I believe are the abundance of open-sourced large pre-trained deep learning models and how the embeddings generated from open source. The major new development in the past year, 2023, is the ability to apply these models, frameworks and embeddings also for real-time use cases such as recommendations or sentiment analysis, using vector databases for vector similarity search with filtered searches. This not only extends the application of embeddings to a wide variety of real-time use cases, it also extends its accessibility to software developers who are not data science or machine learning experts. It enables developers to enrich any application with AI, with a few lines of code. 5. For machine learning engineering, the most exciting development in the past 2-3 years I believe is the emergence of machine learning operations or MLOps. MLOps, machine learning operations, is a set of practices for collaboration and communication between data scientists and operations professionals. Applying these practices increases the quality, simplifies the management process, and automates the deployment of machine learning and deep learning models in large-scale production environments reliably and efficiently. It's easier to align models with business needs, as well as regulatory requirements. In 2023, MLOps has evolved into an independent approach to ML lifecycle management. It applies to the entire lifecycle: data gathering, model creation, software development lifecycle, continuous integration, continuous delivery, orchestration, deployment, health, diagnostics, governance, and business metrics. The key phases of MLOps are data gathering, data analysis, data transformation, preparation, model training and development, model validation, model serving, model monitoring, model retraining. 6. The most important language to learn isn't Python, it's SQL. Databases of all sizes are on a tear. Many workloads are moving to the cloud, and powerful cloud data warehouses in particular, finally reaching a tipping point as a combination of features and price make it difficult for any company to hold out. And when data is available locally, new in-memory databases like DuckDB make it possible to use advanced, SQL-based query engines from a laptop, from a serverless function, even from the browser itself. These pervasive SQL-based tools are crowding out yesterday's heavily scripted approaches to data manipulation because they empower users to work with data where it sits, rather than have to extract it, manipulate it, and reinsert it. SQL is certainly an easier language to learn than Python. It has a very basic syntax that has the sole purpose of communicating with relational databases. Since a great amount of data is stored in relational databases, retrieving data using SQL queries is often the first step in any data analysis project. 7 megaliters and AI is just about everywhere now. In technology industry, we have received many inquiries this past year about developing ML and AI products for customers, and a common story I hear is that we have many models running in production but we don't really understand why they work, when they will break, and how to fix them. For many companies, their ML/AI deployments have evolved into incredibly complex systems, and the winners will not be the ones who build the best and most accurate models, but the ones who can manage this complexity. In particular, while it has become much easier to build and deploy ML models, managing the underlying data has become much harder. Data quality, access, and governance remain deep challenges for companies looking to leverage ML and AI. In my experience, the key challenge facing data governance is what I call data quality mismatch. Contrary to common beliefs and the never-ending complaints from data scientists that their data is of low quality, it is just not high enough quality for the ML or AI product they are trying to build and maintain today. Many companies are trying to build ML and AI solutions for more complex products, using data collected from older, existing, and simpler products. Consequently, the quality of this older data is only good enough for the product this data was originally designed for. For example, data cannot simply be moved from a low-quality reporting product and reused in a high-performance ML product without expecting to find numerous and exhausting data quality issues. An issue that had no material impact on the original reporting system. Once dominated by public sector applications given their all-over access to the data, the commercial sector saw dozens of spatial analytics applications moved into production in 2023. This means that computing facilities can be accessed from anywhere over the network using any sort of thin or thick clients, for example smartphones, tablets, laptops, personal computers, and so on. Cost of sensors and devices that generate geospatial data is falling rapidly with corresponding proliferation. The cost of location-enabled chips for cellular connectivity has declined by 70% over the past 6 years. Costs of launching a satellite have fallen sharply over the past decade on a per-kilogram basis, meaning more data collecting satellite launches. The expansion of 5G networks is aiding in the collection of greater volumes of geospatial data. The result is that in 2023, connected devices capable of sharing their location generated over 15 zettabytes of data, making location-enriched sensor data the fastest-growing kind of data in the world. Spatial analysis in particular is extremely compute-intensive, which has historically limited the amount of data that can be processed or required exotic and expensive GPU architectures that were out of reach for most organizations. Recent advances in query vectorization, which is data-level parallelism, have significantly improved the efficiency of windowing functions, derived columns, and predicate joins essential to advanced spatio-temporal analytics at scale. Also, as the energy sector moved quickly in 2023 to respond to supply shortages, companies like SM Energy are fusing drill bit sensor readings with geological readings at a scale that was previously intractable, resulting in faster well drilling at lower costs. T-Mobile extended their lead as the fastest 5G network as measured by download speeds per open signal, by fusing cell phone signals on spatial dimensions with buildings and roads to detect and address 5G coverage weak spots, resulting in better cell service for customers. What are the challenges in oil and gas? Machine learning is already making a positive impact across many industries. However, the transition will not happen overnight. As the oil and gas industry prepares to incorporate machine learning, it is important to recognize the challenges involved. Increased need for scientists. The first significant challenge is the oil and gas industry's need to hire data scientists qualified to extract knowledge from industry data. This may be difficult for companies that already have a shortage of workers or companies in regions where there aren't many people with data science skills. Data processing power. Another challenge is the large amount of data oil and gas companies deal with daily. This means that the machines doing the analysis will need to be very powerful to process it all in a reasonable amount of time. Upfront time investment. Finally, training the machine learning algorithms to recognize valuable data patterns for oil and gas companies will require a great deal of time and effort. However, the payoff of accurate models to make data-backed decisions will be worth it for oil and gas companies. The realization that machine learning techniques can be successfully deployed for oil and gas companies is still occurring across the industry. As more energy companies investigate ML use cases, we will see an increase in its adoption. This will certainly change how oil and gas companies operate, and it is just one example of how data science is changing how we do business. In my opinion, the most important challenge that oil majors are facing these days is growing supply chain complexity, with ever-growing network consolidation and restructuring combined with greater dependency on third parties across the value chain. The increasing cost of service is another major challenge. This is driven by rising supply chain costs due to operational inefficiencies, hybrid back-office operations, and other factors. Poor cross-functional and intra-company collaboration is a third key challenge. A lack of integrated supply chain planning and execution, limited flexibility for event and exception-based planning, and absence of real-time insights combine to complicate collaboration and decision-making. As someone who has been professionally involved for a number of years at the intersection of technology and energy, I have witnessed firsthand the challenges and opportunities faced by recent price changes. Cybersecurity-related challenges in the oil and gas industry. The oil and gas industry is no stranger to major cybersecurity attacks, attempting to disrupt operations and services. Most of the best understood attacks against the oil industry are initial attempts to break into the corporate networks of oil companies. It is important to have an in-depth at cyber attacks that can disrupt oil and gas companies because they affect operations and profit in a major way. By looking closer at the infrastructure of an oil and gas company and identifying threats that can disrupt operation, a company can seal off loopholes and improve their cybersecurity framework. Trend Micro identified the following threats that can compromise oil and gas companies, which are quite handful. I will suggest you to read the detail from there. Few of them are the common threats apply to any other industry. The infrastructure of a typical oil and gas company. An oil and gas company's product chain usually has three parts: upstream, midstream, and downstream. Processes related to oil exploration and production is called an upstream, while the midstream refers to the transportation and storage of crude oil through pipelines, trains, ships, or trucks. Lastly, the downstream, the production of end products. Cyber risks are present in all three categories, but for midstream and upstream, there are few publicly documented incidents. Generally, an oil company has production sites where crude oil is extracted from wells, tank farms, where oil is stored temporarily, and a transportation system to bring the crude oil to a refinery. Transportation may include pipelines, trains, and ships. After processing in the refinery, different end products like diesel fuel, gasoline, and jet fuel are transported to tank farms, and the products are later shipped to customers. A gas company also typically has production sites and a transportation system such as railroads, ships, and pipelines. However, it needs compressor stations where the natural gas is compressed before transport. The natural gas is then transported to another plant that separates different hydrocarbon components from natural gas, like LPG and cooking gas. The intricate process of oil and gas companies mean they require constant monitoring to ensure the optimal performance measurement, performance improvement, quality control, and safety. Monitoring metrics include temperature, pressure, chemical composition, and detection of leaks. Some oil and gas production sites are in very remote locations where the weather can be extreme. For these sites, communication of the monitored metrics over the air, fixed, optic or copper, lines, or satellite is important. The systems of an oil and gas company is typically controlled by software and can be compromised by an attacker. Threats. There are several threats that oil and gas companies should be aware of. The biggest threat to the industry is those that have a direct negative impact on the production of their end products. In addition, espionage is something that such companies need to defend themselves against, too. There's a correlation between digitizing the core and a lower break-even price. While many factors determine the break-even price, the correlation with digital suggests that digitally mature companies can positively affect the break-even price by increasing production, reducing capex, and/or reducing opex. Finally, evidence also suggests that companies advanced in adopting new ways of working, such as agile and multidisciplinary teams, have higher free cash flow. The future of data science, machine learning, and AI in the oil and gas business. Here we dive into the oil field of the future and where technology is taking it next, from drone and robot-based exploration to carbon source capture and geothermal wells. The oil field of the future will be built on key technologies such as drone and robot-based exploration to reduce capital costs and time to production, nanosatellite monitoring to reduce ongoing operation and maintenance costs, aerial gas leak detection to detect and address methane emissions, carbon source capture to reduce overall greenhouse gas emissions, geothermal wells to increase oil field productivity and sustainability. Oil and gas companies are already using machine learning to help with prediction models, produce better results from their resources, and optimize their processes. Machine learning has the power to revolutionize the oil and gas industry. This forward momentum is crucial for the sector solely responsible for keeping the rest of society moving. In the coming years, we will see more and more ML technologies used by oil and gas companies around the world. In fact, the future of the oil and gas industry can be found in the convergence of many different technologies, including machine learning. Companies who adapt early can improve their resource optimization and gain a more detailed look at their progress. 9. In 2023, we witnessed an ever-growing, cross-industry and robust adoption of AI algorithms and data science techniques, both among data citizens as well as in large organizations. Traditional one-man businesses such as physicians, teachers, accountants, consultants, auditors, lawyers, and many other professional figures understood the value of data and embraced a data-informed culture to innovate and stay competitive. To close the gap, reduce upskilling costs, idle time and money, and leverage the power of AI-driven solutions, the adoption of low-code, no-code data science platforms became more prominent than ever before. Through intuitive visual interfaces, these platforms enable data citizens to build data workflows and collaborate with software experts and data scientists, triggering a positive snowball effect on their job performance. The higher complexity and diversification of data science operations sharpened the standardization of roles in the analytics industry. In 2023, organizations abandoned the inherently erroneous concept of the unicorn data scientist and moved towards different data professional figures and standardized data roles. Data curators, data engineers, data scientists, data analysts, automation specialists, ML engineers, just to name a few, became recognized job titles, each with a specific education background and set of skills. Finally, the AI maturity of organizations and the appearing on the scene of data citizens has favored a number of data literacy initiatives. Following this need and considering the post-COVID scenario, the number of courses, events, books, videos and other initiatives surged, especially in the second half of 2023, to keep up with the demand. All of this together creates a strong incentive for more conservative companies to heavily invest in these practices, which are more often than not accelerated by employees eager for more automation, more analytics, and more insight. This year we witnessed many layoffs and resignations of data analytics professionals across all levels and companies. Many companies are working hard to retain top talent, investing in training programs and providing employees with growth opportunities. Others have cut down on spending and are holding back on investing in their people in fear of an economic downturn. In addition to economic pressures, tech companies are facing tough decisions around letting their employees work remotely versus bringing them back in the office, at least part-time. Those that provide the right balance of flexibility stand to win the competition for top talent. Top 4 tech firms, Meta, Amazon, Microsoft and Google based in USA announced over 97,000 job cuts in 2023 according to consulting firm Challenger. However, the demand for data analytics, data science, and AI/ML professionals holds strong as we face an increased reliance on AI to carry out repetitive tasks, as well as even more data to analyze than we had last year. One thing I'm noticing is that we are still seeing a disconnect between the supply of talent available. The majority are non-senior data scientists, data engineers, and the demand for senior data professionals that can fill the needs of the hiring companies. I can't wait to see what the new year brings. 11. Automating ML workflows will become more essential. Although we've seen plenty of top technology companies announce layoffs in the latter part of 2023, it's likely none of these companies are laying off their most talented machine learning personnel. However, to fill the void of fewer people on deeply technical teams, companies will have to lean even further into automation to keep productivity up and ensure projects reach completion. We expect to also see companies that use ML technology put more systems into place to monitor and govern performance and make more data-driven decisions on how to manage ML or data science teams. With clearly defined goals, these technical teams will have to be more KPI-centric so leadership can have a more in-depth understanding of machine learning's ROI. Gone are the days of ambiguous benchmarks for ML. 12 hoarding ML talent is over. Since ML and AI has become a more common technology in the last decade, many big tech companies began hiring these types of workers because they could handle the financial cost and keep them away from competitors, not necessarily because they were needed. From this perspective, it's not surprising to see so many ML workers being laid off considering the surplus within larger companies. However, as the era of ML talent hoarding ends, it could be a new wave of innovation and opportunity for startups. With so much talent now looking for work, we will likely see many of these folks trickle out of big tech and into small and medium-sized businesses or startups. 13 Everyone's an artist with generative AI. In 2023, there were many cutting-edge developments in the area of MLOP's tooling, generative art, large language models, and speech recognition. OpenAI and DeepMind were at the forefront of AI development. They are always coming up with the state-of-the-art models which transform the whole industry. DALL-E 2 was introduced by OpenAI, and soon after, we have seen people using natural language to generate high-quality art. It was just amazing. Soon after its launch, we saw the DALL-E 2 open-source version, Stable Diffusion for Generative Art. It allows people to understand the model architecture and come up with a unique solution such as diffuse the rest. Both Stable Diffusion and DALL-E 2 are mainstream now. 14 MLOP's tooling. In the past, there were limited open-source tools available for us to smoothly deploy the models into production. Either we have to use DevOps tools or come up with unique solutions. There was no one-stop solution. We had to use multiple MLOP's tools for experiment tracking, metadata management, ML pipelines, data and pipeline versioning, and model monitoring. It has all changed in 2023. The product-based companies are integrating more features for data scientists and machine learning engineers to perform all of the MLOP's tasks on one platform, such as DAGS Hub, Kubeflow, and Bento ML. You will see more companies are targeting data scientists and ML engineers, instead of developers and software engineers. The results of these technologies are all quite impressive in their own right. For a long time it seemed like this would be the biggest story of 2023 by far. Number 15. We have seen GitHub Copilot using a large language model for code generation. It has completely changed how we code. GitHub Copilot uses the OpenAI Codex to suggest code and entire functions in real time, right from your editor. Then, OpenAI introduced Whisper, which approaches human-level robustness and accuracy in English speech recognition. It is a little bit better than Wave 2 Vec 2 for the English language. In the end, OpenAI has introduced ChatGPT, which is better than GPT-3. It was optimized for conversation, and you will see a lot of tweets and posts praising how accurately ChatGPT has responded to the question. It is not difficult to see, however, how one could consider ChatGPT the biggest development in the fields of data science, machine learning, AI and analytics for 2023. Sure, it's built on the shoulders of giants such as GPT-3, but that makes it no less impressive. I could link to some of the various interesting results of chats with the model, but you've likely seen many yourself. People have used it as a productivity tool, an assistant, a replacement for Google, a code reviewer, and for all types of other scenarios. In my judgment, there's just no getting around the fact that ChatGPT emerged late in the year to steal the spotlight regarding top developments of 2023. 15 Here I take a second and ask ChatGPT on that note, which we asked to weigh in on the top developments of 2023. What do you think were the key data science, machine learning, AI and analytics developments of 2023? I'm sorry, but my knowledge cutoff is 2022, so I am unable to provide information about developments in 2023. However, I can tell you about some key developments in data science, machine learning, AI, and analytics that have occurred in the past. Some examples include the development of deep learning techniques, the increasing use of big data and cloud computing in machine learning and AI applications, the rise of automation and machine learning in business and industry, and the increasing use of data analytics in a variety of fields. Data science, machine learning, ML, and AI is having a critical impact on the oil and gas industry and is becoming an important technology for industry stakeholders. Data science, machine learning, and AI. Data science focuses on managing, processing, and interpreting big data to effectively inform decision-making. Machine learning leverages algorithms to analyze data, learn from it, and forecast trends. AI requires a continuous feed of data to learn and improve decision-making. This AI process can be compared to the way people learn. Children don't need to be programmed to understand the world. Instead, they learn by watching their parents and the environment around them. As they learn and grow, they behave differently based on their new experiences and focus on the things that bring the most value. Similarly, machine learning can help oil and gas companies use data to focus more of their time on the highest value opportunities. Of course, the more data companies have, the better their machine learning opportunities will become. This is an exciting prospect for oil and gas companies, which regularly deal with mountains of information about oil and gas pipelines, well testing, geophysical data, and much more. An accurate statistical analysis of this data can help make millions of dollars difference to a company's bottom line. Data science, machine learning, and AI in the oil and gas industry. ML in the oil and gas industry can be divided into three main categories. 1. Extraction of knowledge from data. As mentioned, the oil and gas industry generates enormous data. However, that data is of little use stored in a logbook or computer program. With the help of machine learning, this data can be processed to make the inferences and decisions that can shape a company's trajectory. 2. Predictive analytics for planning and forecasting. Oil and gas companies can also put past data to use, such as one well's oil production history or a collection of seismic surveys done in a certain area. Machine learning can help companies use that data to make predictions. For example, if a company has collected data regarding how oil production from wells typically varies during the year, they can use machine learning to predict how much oil will be produced in future years. This knowledge can then be used for long-term planning to make the oil company more profitable. 3. Optimizing production through data. When oil and gas companies are extracting fuels from the earth, it is critical to do so as efficiently as possible. Machine learning can help companies use their data to identify the most efficient ways to set up production. This can include anything from determining optimal well spacing, deciding where to drill, and testing different techniques for fracking. These three categories exhibit how machine learning can help oil and gas companies make better decisions today and plan for the future based on past data. This will be critical as they face the challenges of improving their workflow while adapting to new technologies. There are 4 exciting digital technologies and they are transforming the oil and gas industry. 1. AI and data science in O&G. Advanced analytics, big data and AI, artificial intelligence, can enable powerful analytics platforms to provide insights for improved operational and managerial efficiency to reduce disruptions across the oil and gas supply chain. Advanced analytics combined with cloud software can provide significant infrastructure cost savings. Seismic data. During location search for oil drilling, advanced analytics can analyze seismic data to provide risk insights, increasing the success rate and saving time and money. Seismic data analytics can also be combined with historical data to identify oil levels in reservoirs. Predictive maintenance. Big data gathered from expensive machines working on offshore drilling platforms can be used for predictive maintenance of assets and reduce failures. 2. Industrial IoT in O&G. Monitoring pipelines. Leaks and damages in oil and gas extraction can cause significant financial and environmental damage. IoT, Internet of Things, can allow efficient monitoring of pipes, pumps, and filters in the system with real-time data to avoid these leaks. This reduces unnecessary manual checks of the system, and workers are only deployed when anomalies are detected. Asset monitoring. IoT-enabled sensors can provide remote access to usage and maintenance data of heavy machines installed in offshore drilling that are located in remote areas with extreme conditions. IoT in oil refineries. IoT-enabled sensors can also provide real-time data to control performance parameters. As a result, real-time data is available around the clock to achieve accurate measurements. Oil and gas logistics. Since oil and gas-containing ships are big, some areas are inaccessible. LPWANs, low-power wide-area networks, provide monitoring capability to the workers on the ship with real-time data for maintenance. 3. Automation in O&G. The global market value of automation technology in the oil and gas sector is projected to almost double and reach around $42 billion by 2030. The implications of automation in the oil and gas sector are RPA and intelligent automation. Automating the closing process through RPA, robotics process automation, can significantly reduce closing time, reduce the risk of human errors and improve auditability in the oil and gas sector. Automating O&G supply chains. Through RPA, procurement transactions can be automated to improve cycle times and achieve overall efficiency in oil and gas supply chains. Drones in offshore drilling. Drones and submersible bots are used to automate the inspection of inaccessible areas in offshore drilling. Bots can also reduce errors and increase worker safety while installing new parts and repairing existing ones in risky locations. 4. AR and VR in O&G. The AR, augmented reality, and VR, virtual reality, market is projected to increase 10 times to $300 billion by 2024. The implications of AR and VR in the oil and gas sector are improved training. VR headsets can give practical training to workers without the need to visit offshore plants. This can provide an efficient and safer way of applying theoretical knowledge in practical cases. Improved maintenance. AR headsets can provide hands-free instruction steps and relevant tools and parts. This can significantly increase maintenance efficiency, providing graphical information and eliminating the need for reading lengthy manuals. Additionally, these AR headsets can also provide live video access to technicians who are not available at the maintenance location and also record the process for the future. Data science, machine learning and AI applications in the oil and gas industry. There are several areas where machine learning can be applied to help improve oil and gas industry workflows, including 1. Real-time drilling. 2. Reservoir engineering. 3. Oil and gas production and procurement. 4. Downtime prevention. 5. Well testing. 6. Geophysical analysis. 7. And more. 8. What many people do not yet realize about machine learning is how it can benefit humans on the job. 9. The above application areas include a wide range of tasks that involve oil and gas industry employees. 10. Machine learning can help these employees become more efficient at their jobs, help them make better decisions, and improve the quality of products they produce. Machine learning in oil and gas can be used to enhance the capabilities of this increasingly competitive sector. Not only can it help to streamline the workforce, the technology can also be used to optimize extraction and deliver accurate models. These benefits are just some of the reasons why machine learning in oil and gas is becoming increasingly important. Here are 10 ways that the impact of machine learning in oil and gas industries is being felt. Accurate modeling. Pinpointing exactly where to dig with machine learning. Applying machine learning in oil and gas to improve subsurface characterization. Optimizing drilling operations. Solving problems quickly with machine learning applications. Predictive maintenance. Internet of Things. Predictive software for energy purchases. Customer market. Replacing manual workers. Machine learning to predict operational outcomes. One of the most noticeable impacts of machine learning in oil and gas-focused industries is how it transforms discovery processes. Applications employing machine learning in oil and gas enable computers to quickly and accurately analyze huge amounts of data. This includes being able to sift precisely through signals and noise in seismic data. After this information has been gathered and analyzed, modern software applications can construct accurate geological models. This allows operatives to predict, accurately, what is beneath the surface before drilling has begun. It is believed that, if adopted over the entire industry, this will decrease the number of dry wellheads by 10%. There are several artificial intelligence problems, and we are going to address these challenges and how to solve them. 1. Computing power. The amount of power these power-hungry algorithms use is a factor keeping most developers away. Machine learning and deep learning are the stepping stones of this artificial intelligence, and they demand an ever-increasing number of cores and GPUs to work efficiently. There are various domains where we have ideas and knowledge to implement deep learning frameworks such as asteroid tracking, healthcare deployment, tracing of cosmic bodies, and much more. They require a supercomputer's computing power, and yes, supercomputers aren't cheap. Although, due to the availability of cloud computing and parallel processing systems, developers work on AI systems more effectively, they come at a price. Not everyone can afford that. With an increase in the inflow of unprecedented amounts of data and rapidly increasing complex algorithms. 2. Trust deficit. One of the most important factors that are a cause of worry for the AI is the unknown nature of how deep learning models predict the output. How a specific set of inputs can devise a solution for different kinds of problems is difficult to understand for a layman. Many people in the world don't even know the use or existence of artificial intelligence, and how it is integrated into everyday items they interact with, such as smartphones, smart TVs, banking, and even cars, at some level of automation. 3. Limited knowledge. Although there are many places in the market where we can use artificial intelligence as a better alternative to the traditional systems, the real problem is the knowledge of artificial intelligence. Apart from technology enthusiasts, college students, and researchers, there are only a limited number of people who are aware of the potential of AI. For example, there are many SMEs, small and medium enterprises, which can have their work scheduled or learn innovative ways to increase their production, manage resources, sell and manage products online, learn and understand consumer behavior and react to the market effectively and efficiently. They are also not aware of service providers such as Google Cloud, Amazon Web Services, and others in the tech industry. 4. Human level. This is one of the most important challenges in AI, one that has kept researchers on edge for AI services in companies and startups. These companies might be boasting of above 90% accuracy, but humans can do better in all of these scenarios. For example, let our model predict whether the image is of a dog or a cat. The human can predict the correct output nearly every time, mopping up a stunning accuracy of above 99%. For a deep learning model to perform a similar performance would require unprecedented fine-tuning, hyperparameter optimization, large dataset, and a well-defined and accurate algorithm, along with robust computing power, uninterrupted training on trained data and testing on test data. That sounds a lot of work, and it's actually 100 times more difficult than it sounds. One way you can avoid doing all the hard work is just by using a service provider, for they can train specific deep learning models using pre-trained models. They are trained on millions of images and are fine-tuned for maximum accuracy, but the real problem is that they continue to show errors and would really struggle to reach human-level performance. Five. Data privacy and security. The main factor on which all the deep and machine learning models are based on is the availability of data and resources to train them. Yes, we have data, but as this data is generated from millions of users around the globe, there are chances this data can be used for bad purposes. For example, let us suppose a medical service provider offers services to 1 million people in a city, and due to a cyber attack, the personal data of all the 1 million users fall in the hands of everyone on the dark web. This data includes data about diseases, health problems, medical history, and much more. To make matters worse, we are now dealing with planet-size data. With this much information pouring in from all directions, there would surely be some cases of data leakage. Some companies have already started working innovatively to bypass these barriers. It trains the data on smart devices, and hence it is not sent back to the servers, only the trained model is sent back to the organization. 6. The bias problem. The good or bad nature of an AI system really depends on the amount of data they are trained on. Hence, the ability to gain good data is the solution to good AI systems in the future. But, in reality, the everyday data the organizations collect is poor and holds no significance of its own. They are biased, and only somehow define the nature and specifications of a limited number of people with common interests based on religion, ethnicity, gender, community, and other racial biases. The real change can be brought only by defining some algorithms that can efficiently track these problems. 7. Data scarcity. With major companies such as Google, Facebook, and Apple facing charges regarding unethical use of user data generated, various countries such as India are using stringent IT rules to restrict the flow. Thus, these companies now face the problem of using local data for developing applications for the world, and that would result in bias. The data is a very important aspect of AI, and labeled data is used to train machines to learn and make predictions. Some companies are trying to innovate new methodologies and are focused on creating AI models that can give accurate results despite the scarcity of data. With biased information, the entire system could become flawed. How AI can improve businesses in the coming years. Large companies like Apple and Google have invested heavily in developing artificial intelligence. Beyond those businesses, AI is frequently underused in other sectors, including manufacturing, education, retail, and healthcare. All these businesses produce enormous volumes of data every single day, but AI is rarely used to analyze massive datasets and draw conclusions from these patterns and features of that data. The main question is, why is the issue so prominent? Lack of access, comprehension, and abilities are the cause. We have read about the top problems with AI. We need to learn what can bridge the gap between those AI problems and the profitability of a business. One of the biggest artificial intelligence problems is that the sophisticated and expensive processing resources needed are unavailable to the majority of businesses. Additionally, they lack access to the expensive and scarce AI expertise required to utilize those resources effectively. As of 2022, 37% of businesses have already employed AI services and continue to do so. According to a study, the AI industry will earn $126 billion every year by 2025. According to Forbes, AI will become a $15.7 trillion industry by 2030, and investments will hit approximately $500 billion by 2024. Here are 3 ways in which AI can help scale businesses and overcome the above-mentioned problems with AI. Utilize the already existing AI technologies. Businesses no longer need to train their AI from the start because there is already so much AI work being done on the cloud, which is available at large, unlike the older models with AI problems in artificial intelligence. They can profit from the already done labor by the other companies. They are able to adapt already working AI technologies to suit their own demands. But they are unable to do so without a user-friendly, intuitive interface. During the past few years, we keep coming across headlines that alert us how artificial intelligence, AI, will take over our jobs and that robots will rule the world. However, in the sea of dystopian information, we can also encounter the positive impact of AI, helping us make the world a better place. In the global attempts of achieving sustainability, and more notably, meeting the UN Sustainable Development Goals, SDGs, AI can become a powerful weapon towards a circular economy and more sustainable living. With AI's undeniable rising popularity, it will be applied to a myriad of industries and will be leveraged for a variety of causes such as environmental sustainability. As the field of AI continues to thrive, companies with massive ecological impressions can leverage the field's power to make serious changes to our world as we know it. If anything, right now is a historic time in artificial intelligence. With advancements in big data, hardware, and emerging powerful AI algorithms, it seems like all the pieces are coming together to make huge changes to our everyday lives. Saving planet Earth doesn't seem as hard as it used to be because of these advancements. Sustainability. What is sustainability in digital technology? Digital sustainability is the process of applying social, economic, and environmental stewardship principles to digital products, services, and data delivered via the Internet. Designers and developers might interpret this as a call to deliver more resource-efficient digital products, and they would be right. Citizens, businesses, and policymakers are all facing enormous tasks. Green transformation will require businesses to develop new, sustainable infrastructures, economic systems, and value creation networks. Policymakers will have to create conducive political frameworks, conditions, and incentives. Finally, Everyone will have to work together to transform our socio-cultural playing field. In practice, this means digitalization must be carried out in a way that has positive effects on sustainability. We cannot allow digitalization efforts to reinforce unsustainable behavior patterns or economic practices that damage the environment and exacerbate the current environmental crisis. Digital transformation itself, i.e. its technologies, infrastructures, and business models, must be sustainable by design, and the environmental impacts of digitalization must be minimized. Digitization is the translation of information from the physical world into electronic signals. It is a prerequisite for digitalization and fundamentally enables the decoupling of information from the limitations of time and space, thus giving unlimited information usability. This digital mapping of the world is becoming increasingly accurate. Under Industry 4.0, for example, digital twins for plants and processes enable comprehensive optimization within virtual environments. In addition, information availability is now the basis for new sustainable services, such as in local sharing or repair economies. Digitalization is characterized by extremely dynamic innovation, especially in key technologies such as sensor technology, data transmission, and chip technologies, as well as in certain types of data analysis such as artificial intelligence processes. Technological progress is rapidly changing the way data is collected, connected, shared, analyzed, and used for decision-making and interventions in the physical world. New applications are constantly emerging, and the scope of these applications is ever expanding. Digital technologies and applications are critical to green transformation since they are capable of radically changing the way we organize work, production processes, human behavior, and business models. These radical changes are where the greatest opportunities lie, and so we must seize them while we can. Over the next few years, society will have to create conditions that enable us to organize our lives and economies within the framework of the Sustainable Development Goals. Achieving this will require a fundamental change of direction in all key areas of action across all sectors. For structure, we refer to the transformation arenas: energy, resource, and water management, mobility, consumption, city management, agriculture, nutrition, education, and health. These sectors are all currently waiting on comprehensive system transformation in terms of political frameworks, incentive systems, market structures, infrastructures, value chains, and behaviors. Artificial intelligence, AI, has become an important area to tackle most environmental sustainability issues such as biodiversity, energy, transportation, and water management. Biodiversity research has developed machine learning or natural language processing solutions to predict ecosystem services. Artificial intelligence applications and machine learning models have been increasingly used for predicting and optimizing water resource conservation. Area neural network, expert systems, pattern recognition, and fuzzy logic models are the main focus areas in energy. Applications of computer vision and decision support were found in transportation. Timely monitoring of interventions is required to improve environmental sustainability. Addressing environmental sustainability challenges is complex, but with the introduction of AI, most of the common environmental problems become simple to address by putting the interest of the people in action. The environment, economy, and society are interrelated dimensions of sustainability, where sustainability, according to the UN document titled Our Common Future, also referred to as Brundtland Report, defines sustainability as sustainable development, and sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Environmental sustainability as defined simply as meeting both the resource and service needs of present and future generations, where the health of the ecosystem is not compromised for humanity. Artificial intelligence refers to the ability of any machine or computer to mimic human capabilities such as learning from examples and experience, recognizing objects, understanding and responding to language, making decisions, and solving problems. Combining these different capabilities, the machine can perform complex functions such as driving a car. AI has gained popularity due to its successful deployment in applications that were once unthinkable. For instance, talking to Siri or Alexa to set up your calendar. Here are some illustrative examples of companies using AI to be more in line with a sustainable future. Google uses an AI model to reduce the energy load of its resource-hungry data centers, reducing the energy cost of cooling by 40%. IBM is using AI for better weather forecasting, making their predictions 30% more accurate. This helps renewable energy companies to better manage their plants, maximizing renewable energy production, and reducing carbon emissions. Xcel Energy, a coal-burning and nitrous oxide-emitting utility company, is using AI to better predict energy consumption patterns and adapt its operating systems, thus significantly boosting efficiency, approximately 20%. Carbon Tracker, a climate advocacy think tank, uses AI to track emissions from coal plants using satellite imagery. Using satellite data, they help guide investments toward lower footprint ventures. Leading companies understand that achieving ambitious sustainability goals requires a systemic approach to transformation, one that takes a 360-degree view of the challenge. Building sustainability as a competitive advantage, however, requires integrating technology and data from the very beginning. The role of tech goes well beyond green IT. As more companies think about their technology and sustainability agendas in concert, management teams should ask whether they are bringing game-changing technology and digital thinking to the task of meeting sustainability goals, or whether this critical business issue is missing an important dimension. The technology eco-advantage. For companies willing to think broadly about how to advance their sustainability initiatives, technology can act as a major accelerant. We call this mindset, technology eco-advantage, using advanced technologies and ways of working to enable profitable solutions that also have a positive impact on net zero and other environmental, social, and governance goals. Take the example of achieving net zero GHG emissions. Our experience shows that for an organization of about 80,000 people, the combination of process automation, carbon data transparency, circular product or service design, and sustainable business models can reduce emissions by 45% to 70%. What are the tech accelerators to advance sustainability goal? Digitized operations. Frontrunners in this area create inherently more sustainable operations and processes. For example, new manufacturing or materials technologies that leverage alternative inputs to reduce emissions and waste, and win consumer and investor reward as a result. Digitized operations also can improve business resilience. Some of the processes and technologies involved even become industry standards. Schneider Electric transformed itself from an installer of industrial electrical equipment to a global leader in efficiency as a service, generating revenues from reducing customers' CO2 emissions. The greater the environmental and social impact that Schneider creates through energy savings and emissions reductions, the more it is financially rewarded by customers and the faster its business expands. Digital products and services. Leading companies create new distribution channels that break economic constraints to expand reach, scale, and access for beneficial societal impact at affordable costs. Apps that digitize and facilitate access to essential goods and services are one example. A major city transportation authority designed 3 customer-centric sustainability solutions that reimagined how parcels are delivered while reducing emissions, transforming the customer experience, and delivering sustainable growth and profit. Cloud, IoT, and blockchain. Advanced digital technologies and tools, such as connected IoT sensors and monitors, cloud-based data platforms, and blockchain-enabled tracking systems, unlock new capabilities for the measurement and tracking of environmental and social impact across value chains. Companies, in turn, can better improve management and investment decisions and improve their performance against ESG goals. For example, value chain transparency solutions that use blockchain technology guarantee the integrity and safety of products from supply source to producer to retailer to consumer. AI and advanced analytics. These technologies generate data and insights on the environmental and social impact of a product, service, or process. Digital platforms integrate capabilities, share data, and create transparency and accountability among partners. Frontrunners leverage these capabilities to develop and fine-tune offerings, engage customers, and improve performance over time. IoT and AI-based solutions also optimize energy efficiency in real time, reducing emissions and saving money all at once. Data sharing and ecosystems. Data sharing enables new models of collaboration within or across industries or sectors to develop novel solutions to environmental and social issues. Companies can more easily pool resources, fill capability gaps, access new markets, and expand reach. For example, software platforms that integrate insurance underwriters and telecommunications providers can deliver microinsurance via phone subscriptions to underserved populations. BCG research into the impact of data sharing on big societal challenges has shown that data sharing generates value in 5 ways: enabling innovation, creating trust, facilitating coordination, raising awareness, and validating hypotheses. Fertilizer producer Yara is developing a new business unit to become an IoT and digitally enabled, smart agriculture leader that improves sustainability by reducing the need for chemical fertilizers by up to 90%. New science based on data the company collects informs the development of next-generation regenerative crop nutrition solutions, taking an early technology LED approach. In 2020, BCG examined 300 corporate sustainability initiatives. Of these, 85 were cases of Sustainable Business Model Innovation, SBMI, that generated both societal and business value. Half of these companies used innovations in products or processes, or changes to the value chain, to mitigate negative environmental impact. Another 25% reimagined value chains and business ecosystems, attempting to address the root causes of environmental and societal needs. The top 25% successfully reimagined their business entirely, reshaping the boundaries of competition to address the root causes at scale for growth and advantage. A key differentiator for these frontrunner companies was using digital capabilities and technologies to break economic constraints and unlock new solutions. But success depends on leveraging technology and data from the very start. Before making a major commitment of time, management energy, and company resources, management should take a forward-looking and strategic view of how advanced technology and data can accelerate the journey to sustainability advantage. "We can't manage what we don't measure," goes the old business adage. This rings true more than ever today as the world faces a triple planetary crisis of climate change, nature and biodiversity loss, pollution, and waste. More climate data is available than ever before, but how that data is accessed, interpreted and acted on is crucial to managing these crises. One technology that is central to this is artificial intelligence, AI. AI can play a role in tackling environmental challenges, from designing more energy-efficient buildings to monitoring deforestation to optimizing renewable energy deployment. As this is the snapshot of real-time analysis from Microsoft that is leveraging AI's capabilities to analyze complex, multifaceted datasets that monitors and monitor and mitigate methane emissions over the passage of time. Reducing the energy sector's methane emissions is one of the quickest, most feasible, and cost-effective ways to limit the impacts of climate warming, and reliable data-driven action will play a big role in achieving these reductions. It can help calculate the footprint of products across their full life cycles and supply chains and enable businesses and consumers to make the most informed and effective decisions. What are the key challenges in applying AI for environmental sustainability? It has been established that artificial intelligence addresses environmental challenges sustainably, but on the other hand, they are challenged on the basis of relying on historical data and machine learning. This is due to the unpredictable and evolving nature of artificial intelligence because the variability of the human behavior is difficult to incorporate into machine learning models. Thus, past data before any extensive human activity reflect ages and climate cycles, and thus estimating potential climate change is difficult. Also, managing variance where past data is fitted into models, as most machine learning practitioners have special attention for them. New data associated with these models can be generalized, and this is a recipe for inaccurately predicting future scenarios, which is technically known as variance bias trade-offs. Also, increased risk of cybersecurity is a challenge in applying AI for environmental sustainability. Cybersecurity risk management is important in data integration for AI applications. However, the rising level of cybersecurity threats as a result of hacking is a major challenge to address environmental sustainability challenges because third parties gain access to critical data and siloed approaches are less effective in minimizing cybersecurity risk. Inadequate measurements of performance and uncertain human behavioral answers to various interventions based on AI support is another challenge in applying AI for environmental sustainability. Measurement and monitoring of interventions are critical in advancing environmental sustainability. The measurement is complex and often unsuccessful, and as such, combining both technical and analytical performance in a holistic metric leads to the success of AI for environmental sustainability. AI applications are as intelligent as humans for decision-making, but its focus is quite different in terms of human responses to decisions. However, it is critical to understand the behavioral responses whilst evading the common problem known to be associated with the advancement of technology as a result of the trap of rebound effects. In the end, I ask the same question to our friend ChatGPT: can AI help achieve environmental sustainability? And here is the answer. Yes, AI can help achieve environmental sustainability in various ways. For example, AI can be used to optimize energy consumption in buildings and industrial processes, reduce waste, and improve resource efficiency. AI can also be used to monitor and manage environmental systems such as forests, oceans, and air quality. Additionally, AI can be used to analyze large datasets to identify patterns and trends that can inform policy and decision-making related to environmental sustainability. Certainly, here are a few specific examples of how AI can be used to achieve environmental sustainability. Energy efficiency. AI-powered building management systems can optimize heating, cooling, and lighting to reduce energy consumption. Additionally, AI algorithms can be used to predict and prevent equipment failures in industrial processes, reducing downtime and energy consumption. Renewable energy. AI algorithms can be used to predict and optimize the output of renewable energy sources such as wind and solar power. This can help to increase the effectiveness and efficiency of these energy sources. Resource efficiency. AI-powered systems can be used to optimize the use of resources such as water and materials in industrial processes. This can help to reduce waste and increase efficiency. Environmental monitoring. AI algorithms can be used to process and analyze large amounts of data from sensors and cameras to monitor environmental systems such as forests, oceans, and air quality. This can help to identify areas of concern and inform conservation and management efforts. Climate change. AI can be used to evaluate the impact of different policies and practices on the environment, such as how much greenhouse gas emissions will be generated. It can also be used to predict future weather patterns and other climate-related phenomena, which can inform decision-making related to climate change adaptation and mitigation. Sustainable transportation. AI can be used to optimize traffic flow and reduce congestion, which can reduce emissions from vehicles. Additionally, AI-powered self-driving cars and drones can be used to make transportation more efficient and reduce the need for fossil fuels. These are just a few examples of how AI can be used to achieve environmental sustainability, and research in this area is ongoing. Thank you for watching.